Right, look my dear student, today we are speaking applications of gravitational force. Which kind of works can done by gravitational force? Gravitational force can do types of works. What are they? Today we are looking them. Look here. First point, one by one I will tell you. Gravitational force with the help of gravitational force, which kind of works can do? Gravitational force leads to formation of tides in sea, in ocean. Tides are possible with the help of gravitational force. Next, gravitational force hold atmosphere at place, hold atmosphere, catch atmosphere in a place. Next, gravitational force keeps the moon in orbit. So gravitational force is keeping the moon in orbit around Earth. Another point there, it keeps the Earth in orbit around the Sun. Gravitational force working two times. Earth is revolving in its orbit due to gravitational force. Moon is revolving around Earth due to gravitational force. Next point is that gravitational force brings the rain back to Earth after evaporation. We are getting rains due to gravitational force. Next, gravitational force helps keeping the feet on ground much more. Our feet keep on ground, running, walking, whatever any other difference. Walking purpose, running purpose, jumping purpose, gravitational force is helping to us. Next, what is the differences between mass and weight? Look here, mass here, weight there. Differences one by one I will compare. Mass, it is quantity of matter contained in a body. Mass is quantity, size of matter. Next, weight is the force with which attracts the objects towards itself. Weight is the force. For example, earth weight is nothing but earth attracting us. That force is called weight of earth. Force of attraction force of any object. Compulsory that object should attract towards itself. When that object can attract towards itself, the attraction force of object is called weight. Next point. Mass unit is kg and weights unit is Newton. We can tell work is equal to mass into gravity. Next, mass remains same every time. It will not change. And now weight value change from place to place as it depends upon acceleration due to gravity. Due to gravity, weight value will be changed. Next concept. When you can look here, mass is equals to, formula wise, mass is equals to matter contained in body. How much matter contained in body, that matter amount of matter can call mass. But what is weight at the time then? Weight W is equal to mass into acceleration due to gravity. W. Weight is equals to mass into acceleration due to gravity is called the weight of one object. Next, thrust. What is thrust here? Thrust, it is the perpendicular force. Which type of force? Look here. Thrust is the perpendicular force. Perpendicular, compulsory should 90-degree maintained, acting on a body. Look here, when you are showing thrust on iron, iron nail, then thumb is 90-degree for nail. Nail is going down, thumb showing force 90-degree. Look here. The upper one is thumb, downer one is nail. So nail is going down, thumb is this side. So 90-degree is maintained by nail and thumb. Here thrust is a force which is acting 90-degree upon any object. That is called thrust. Next, pressure. Look here. Pressure is the force. Very clear. Pressure is the force perpendicular. Pressure is the force per unit area. Upon unit area, what is the pressure? Pressure is the force upon unit area acting on an object. Pressure, when you are showing pressure, then unit area is important. Less area there, then pressure will be more. More area there, pressure will be less. Look here. I will explain you with a few applications. So, pressure is the force per unit area acting on an object. And what is pressure? P is equal to force by area A. Units are Pascal. SI unit is Pascal. And look here, force, pressure P is equal to force by area. It is perpendicular. Force should be perpendicular by area. So this perpendicular force, another word there, thrust, already we seen upward. So thrust by area. Thrust can calculate in Newton by meter square. Thrust can calculate Newton. So here Newton by meter square. Another formula is the Newton by meter square. Directly. Force can calculate by Newton only, na? That's why. Next, look here. What is that? One point I want to say you. Pressure SI unit is Pascal. 1 Pascal is equals to 1 Newton by 1 meter square. So here another one word there. What is that? Pascals. Pressure. Other unit is bar. Pressure containing one more unit. Its name is bar. So 1 Pascal is equals to 1 into 10 to the power of minus 5 bar. That is another value. And after this, look here, pressure's applications. I will explain to you. Look, my dear student, here we are looking applications. Before application, we have two concepts. One, pressure. What is pressure? Here we are taking unit wise. It is said to be, look here, pressure is said to be 1 Pascal when force of 1 Newton acts on 1 meter square area. When force of 1 Newton acts on 1 meter area, 1 meter square area, look here, pressure P is equal to F by A. Newton by meter square. 1 Pascal is equals to units wise 1 Newton by 1 meter square acting, 1 Newton force acting on an object of area 1 meter square. On 1 meter square area, 1 Newton force is working called pressure. Next, look here. Factors on factors on which pressure depends. Look here. Factors are two only. One force, one area. So here pressure is equal to F by A. So here pressure P is equals to proportional to force and pressure P inversely proportional to 1 by area A. Applications of pressure. Look here. Applications 3 I written for you. Please observe there. Applications are 3. What are they? Look one by one. First application, second application, third application. School bags have wide strap size is more. School bags have more wide strap. Why? More is the area, less is the pressure. Already you know. More is the area, less is the pressure. So wide straps are equals to less pressure on shoulders of children. Shoulders will not pay. Next, it is easier to peel vegetables with a sharp knife than a blunt knife. When you are using knife and vegetables, peels removing purpose. So peels removing is easy with a sharp knife. Why? Blunt knife cannot work. Why? Look here. A sharp knife has very less area. Look here, less area. So pressure exerted by sharp knife is more. Pressure exerted by sharp knife is more than vegetables can be easily peeled off. If blunt knife there, vegetable cannot be peeled off easily. Next, it is difficult to move with pencil heels on sand. Girls are wearing pencil heel. When you are looking them, for example, in movies, heroines are wearing pencil heels. So pencil heels. What is that? It is difficult to move with pencil heels on sand. In sand, it is difficult. Why? Pencil heels are equal to have very less area. So the pressure exerted is quite high. As a result, the pencil heels get sunk into the sand. If paragon chappals are there, then they will not sunk into the sand.